I want to talk about the laws of Boolean. We're going to start with the AND gate. Here I've drawn an AND gate. The output of an AND gate we can say is A and B. You'll notice that it's similar to the multiplication. And let's draw the truth table to show that. If we draw a truth table, every combination of A and B, we have two inputs, so we have a possibility. There's two inputs. We have a possibility of 2 to the n outputs. And n equals 2 inputs. So we have 2 to the 2. We have four possibilities of outputs. They could both be low. B could be high. A could be high, or they could both be high. And we want to talk about every possibility and what the output could be for an AND gate. We can liken this to multiplication also. Well, let's say if A is low and B is low, we're going to get a low. They both have to be high in order to get a high output. And so if A is low and B is high, it's still going to be low because they both have to be high. So we're going to get a low again here and finally a high. Now if we look at this with our rules of multiplication, we can, because just the way this is written, even though the answer is A and B, if we multiply 0 times 0, we get 0. 0 times 1, we still get 0. 1 times 0, we still get 0. And 1 times 1, we finally get a 1. So it's similar to multiplication. Now let's take, let's hold B at a certain value, hold this input B at a certain value, and we'll just play with input A, okay? And when we do this, we will start to see what the laws of Boolean are. So if we are able to vary A, but hold B at a certain level, so let's say B is always low. We're going to give it a 0 input, okay? So here's our Boolean laws. A and 0, the result is always going to be 0. Now let's say that the B input is always high, okay? If the B input is high, remember we have to get both inputs high to get a high output. So if B is always high, then the output really depends on what A is. If A is low, the output is low. If A is high, the output is high. So we can say as a Boolean law that A, which is a variable, could be 0 or 1, and always a 1, the output is going to be whatever A is. That makes sense? Now let's take the case of A and not A. And what we're going to do here is I'm going to redraw this AND gate over here, where A could be high or low. But the input of B, we're going to send whatever A is through an inverter and then send it in. And we're wondering, well, what is the output going to be in this case? So if A is high, B is going to be low because it's going to be the inverted of A. If A is low, B is going to be high. So in no case ever in this scenario, will we get a high output. So we're going to, as a Boolean law, we're going to say that A and not A is always going to have a low output. And we have a fourth and final case, A and A, where we're going to remove the inverter here. And simply tie input A to both inputs. And what we'll find out is if A is low, they're both low, and we'll have a 0. If A is high, they're both high, and we'll have an output of 1. So the output is completely dependent on what A is. So A and A always results in A. So there's the Boolean laws for the AND gate. Now we're going to take a look at the Boolean laws for the OR gate. So let's take a look at the OR gate. We're going to say that the product, or the output of this OR gate is the result of A or B. You'll notice that I've used a plus sign, but I've said OR. There are 2 inputs, n equals 2, and so there are 2 to the n outputs. That would be 2 to the 2. That would be 4 possibilities of outputs here. So we're going to draw a truth table for the OR gate. This is an OR gate. Every possibility, A could be low, B could be low. A could be low, B could be high. A could be high, B could be low, or they could both be high. The rules or logic, the logic progression, the logic rules of the OR gate state that just one of them needs to be high and we'll get a high output. In the first case, we had A is low, B is low, so we have a low. And here we have one of them is high, so it's going to be high. One of them is high, so it's going to be high. And they're both high, so we're going to have a high output. So there's your truth table for your OR gate. But let's look at our rules of addition and see if this makes sense. If we use this plus sign and call it an OR, 0 or 0, we're going to get a 0. 0 or 1, we're going to get a 1. 1 or 0, we're going to get a 1. And 1 or 1, actually, in Boolean, or in addition, in binary addition, we've got 0 plus 0 is a 0, 0 plus 1 is a 1, 1 plus 0 is a 1, and then a 1 plus 1 is a 0 carry the 1. But here it's just slightly different from your binary. But this is our OR gate. If either one is high or both are high, you're going to get a high. So that's our OR gate truth table. And from there, we're going to go to now our Boolean laws. And this is how they were derived from looking at these OR gates and looking at these truth tables. And we'll redraw this OR gate over here with a variable input A. Could be 0, could be 1, and we're going to hold the other input to some value. Okay, so we're going to do it just like we did for the other ones, and we're going to say A, and always holding the other input low. A or a low input is always going to be dependent on what A is. If A is high, then at least one of them's high, we're going to get a high. If A is low, then there's nothing high, then we're going to get a low. So it's going to be A plus something at low, A or a low input is always going to be A. Whatever A is, that's what your output is going to be. Let's look at the next case where instead of holding this low, we're going to hold this second input high all the time. So A or a high input is going to result in a high output because we only need one of these high, and it will be a high output all the time. And the next case we're going to look at is A or not A. So we're going to put our little inverter in there again so we can see it real easily. First input is A. Second one, we're going to bring it down and invert the A. So we have A and not A. If A is high, then B is low. If A is low, B is high. And we'll always have one of them that is going to give us a 1, and so our output is always going to be 1 in that case. So A or not A is always going to result in a high output. And then our final case, we have A or A, and we'll just get rid of the inverter. And we'll just tie this output A to itself and run it into B. And this one here is going to be completely dependent on what our input is, on what our output is. If we have A is low, we're going to have low and low, and the output is going to be low. If A is high, it'll be high and high, and the output is going to be high. So we're going to say that that is completely dependent on A, so A or A equals A, and this is the rest of your Boolean laws.